I'll be taking you through some of the work we did as a group, with emphasis on the gaps and importance of human factors in aircraft type design and maintenance. So firstly, a little bit about myself. I know Marie gave me a glowing commendation at the start anyway. I'm currently a systems engineer with Lockheed Martin, working on the Merlin Mark II helicopter fleet. Prior to that, I was working on the Shadow aircraft with Raytheon UK, but I started my career within manufacturing engineering at Airbus UK, working primarily on the A320 family, tooling and process design and improvement. So with the society, what I've done is taken that experience of manufacturing design and applied it to human-centered design for maintenance, leading really the contribution to the design and educational aspects of the work. My other co-authors on the team, we had had backgrounds in aviation maintenance. We had an engineer from Rolls-Royce who knew a lot about engines. So we had a real broad spectrum of expertise on the team, of which I was just one. Okay, so I'll start here with a quote from Mr. New, one of the foremost figures in the theory of airframe design analysis. And I put it to you all here that consideration for maintenance is not as prevalent as it should be within aircraft design. My plan today will be firstly to run through the context and the problem as defined by the human-centered design for maintenance team, and also give a background to the body of evidence we used, and also within that have some contextual examples of how problems can manifest. And then following that background and context, we'll run through each of the sections that the report covered, all the way through from professional standards through design regulation, and then towards education and engineer training at the end, before I give you some concluding remarks and allowing questions at the end. So without further ado, I'll jump straight in. So this mind map is where we first started as a group, really. And what we found was that as we defined and explored the problem space, we found that there was common recurring themes throughout that. This allowed us to then formulate our own context and problem statement. So as a team, we found that the environment today contains maintenance errors, costing millions of pounds. Safety within aerospace typically remains high, and that's reinforced by just cultures that are typically fostered by maintenance organizations. But the rate of error is constant. So we're finding the rate of error is about the same, but because we've got those just reporting cultures, safety remains high. Exact costs are known by operators, but typically not made publicly available. So there's a hidden cost there. Within the context of maintenance, there is a real disconnect between the trinity of work as imagined by the designer versus work prescribed in the aircraft maintenance manual versus work as done by the maintainers. Look out for that trend in following slides, by the way. Within design organizations, OEMs, design is always a compromise, but we are finding that maintenance is very low on that priority list, with things like fuel economy, reduced weight, and passenger experience typically having more priority within design organizations than design for maintenance. So the problem as we defined it is, how do we improve human-centered design for maintenance? Okay, so then secondly, jumping into the body of evidence, we analysed air accident investigation branch reports from 2010 to 2021. So that was circa 70 incidents and accidents. Of those, around 3% we found maintenance was a sole causal factor. 65% was a contributing factor, with the other 32% being deliberate acts such as corner cutting or non-approved repairs. So there's a big body where maintenance is either a causal or a strong contributing factor. Correct installation and inspection are the two most prevalent error types we've got. So you can see component it being incorrectly installed, 54%, damage not being detected, 28%. We found that unclear ICAs, that's instructions for continued airworthiness, such as the maintenance manuals, are significant contributing factor, with maintenance and inspection procedures difficult to perform. We found that within those reports, it's clear that there is a gap between that maintenance trinity, the maintenance as imagined, prescribed, and as done as well. And we found that remedial action taken is often on a tactical reactive basis, and little is being done proactively to address maintenance errors strategically. So next, I'll provide some examples on that. So these are just 3 of those 70 that we investigated as a team. The first one on the left, the flyby, the Embraer ERJ 190, back in 2019, during a compressor wash procedure, the engine run, the high power engine run, was a recommendation and not a requirement written into the AMM. So because it was recommended, the maintenance team didn't do it. Because they didn't do that, there was too much compressor wash fluid in the engine. During taxi, there was fumes in the cabin, which caused a full evacuation of the aircraft. There was an injury to a passenger during that evacuation, and the affected engine was scrapped due to the damage, due to that fume damage. A similar one, A321, during a biocide treatment, the AMM specified 100 ppm, but nowhere did it specify what ppm meant. It didn't tell the engineer how to calculate it, and the maintainer relied on the internet search engine to calculate the correct quantity of biocide. And in the end, it was 38 times too concentrated. So the result was, during takeoff, the engine had surges, they had a mayday and returned to field, and there was significant contamination to the fuel system and engine found as a result. And the last one on the right there, the Enstrom 280FX, after the crash, they found that the gearbox oil quantity was insufficient, but in the AMM, there was unclear oil quantity specified, and there was an unclear servicing period as well, which resulted in injury to the pilot, and the entire airframe was scrapped. So that's how we typically see these maintenance errors contributing to crashes and accidents. All right, so next what I'll do is I'll jump into each section that we considered as a team when we were doing the human-centered design for maintenance report, starting with professional standards and particularly comparing engineering chartership versus licensure. So for design engineers working in 21J organizations, there's no requirement to be chartered. It's an elective peer-to-peer assessment, and within that there's no requirement to show human factors competence as part of your chartership journey. Sorry. And it's not written into the UK Engineering Council engineering spec either. Conversely, for maintenance engineers working within Part 145 organisations, human factors is an essential part of becoming licensed. Licensure relies on formal assessments, and as part of that, human factors are an essential part of becoming licensed and being able to work within that Part 145 organisation. So we found there's a lack of standardization really across the aerospace industry related to human factors and against which to grade professionals. There's an opportunity there, but a significant challenge as well to integrate better the grading of professionals across 145, 21, and more broadly the aerospace industry. Coming over to design organizations, requirements and practice as well. So this is where I work within, this is my sort of role within industry. And as a designer, I find there's a general lack of rigor, standards, or awareness of human-centered design for maintenance in the civil design environment. The only real industry-wide standard we've got is the Federal Aviation Administration Human Factors Design Standard, or HFDS. That design standard is really focused on anthropometric ergonomy and doesn't consider the more holistic human factors associated with aircraft design, such as cognition, fatigue, error-proof or error evidence design. Other sectors have been more proactive. So we found that industrial engineering, manufacturing engineering have a wealth of guidance, primarily driven by the drive for efficiency and reduced costs. The military sector also has a wealth of guidance, that primarily being driven by the need for high utilization of their aircraft and the need for fast turnaround as well when they're on the ground. Looking at more detail at the requirements, but again, I'll come into more detail on this in the next section as well. Civil regulation is goal-oriented. We aim for targets when we design aircraft. And as part of that, the safety analysis that is performed assumes that no errors is introduced during aircraft maintenance. There's also different standards for OEMs and design organizations to respond to reported occurrences across rotary, light aircraft, small, and the large transport categories there as well. Anecdotally, we've found that there's increasing pressure on design organizations to prioritize cost of operation and fuel economy above all other factors, with maintenance coming a lot lower in that priority list. But there are some good examples. We found that BEng, for example, appoints a chief mechanic from the initial stages of design to champion that design for maintenance. And we believe that there's an increasing need to have those advocates embedded into design teams. On the next couple of slides, I'm going to provide some other examples that we found were good examples. So as I touched on before, manufacturing engineering has some very good examples. These are excerpts that I found in the product design for manufacture and assembly book, sorry. These exemplify some error evident design assembly. So for example, pyramid design is error evident. We've got some good component installation guidance there for tapered shafts. And there's on the right, there's a good example of how to reduce part counts and also how to reduce that FOD risk as well through using blind fasteners. But as I said before, there exists today no single agreed upon design guidance or design book for designers providing guidance for aircraft design and maintenance. I touched on defense before as well. This is an excerpt from Mill Handbook 470 Alpha, which is written by the US Department of Defense. This handbook provides a holistic framework for designing and developing effective aircraft maintenance programs. Of this book, 397 pages are dedicated to the well-bound guidelines you can see here in front of you now. So this is just one out of 397 pages of these sort of guidelines. Now, while guidance about bomb stowage, ammunition loading, etc., isn't applicable to the civil space, what the US Department of Defense have shown here is that it is possible to generate holistic design for maintenance guidance for designers and engineers. Okay, coming on to topic number 5 here, which was certification, the requirements and process. We focused really on EASA here because in the UK, we're sort of bound by the European aviation rules. Now, there are a few certification specifications addressing human-centered design for maintenance, and the few that do exist, we found were tactical responses to accidents and severe incidents. For example, the engine thrust reverser maintenance requirements written into the CSs can be traced back to the Lauder Air accident. So they tend to be just tactical responses to stuff that's already happened, and we found that they're not really proactive. Human-centric requirements are fairly new to civil regulation, with CS 251302, that's the flight deck human factors requirements, being a relatively recent addition to the certification specification. Flight deck requirements, therefore, accept that design has to accommodate realistic human performance. It's therefore incongruous that no similar design requirements exist for design to avoid maintenance error, where we find time and again maintenance error can have just a significant impact on safety as flight deck design. Looking ahead into the future, though, EASA have stood up a team investigating their safety issue 9006, which is shortcomings in design and maintenance instructions resulting in maintenance errors. The RAeS HCDFM team have members sitting on that investigation team. Their final report is due to be released in December next year, so December 25, with potential endorsement the following year. So it is on EASA's radar, and they are doing something about it. It's the good news. Okay, so that's what design organizations and EASA are doing at the moment. So coming down to the grassroots really now, and 6 and 7 touches on education and engineer training, of which I'll do education first. The group researched the 2 typical routes for aviation professionals: vocational routes through apprenticeships, and the more formal graduate route through university as well. Vocationally, in the UK, there are over 850 apprenticeship standards covering everything from retail to butchery and also aircraft design. Apprenticeships in the UK are largely designed by employers alongside their educational partners, so that professionals educated through the vocational route are highly specialised for a particular role in industry. We found that parent companies have an opportunity to embed contextual, therefore, human factors into their apprenticeship specific to the work environment within which that individual will be employed. But there's no widespread effort to do so yet. Looking at the more formal route through university, universities offer courses containing several mandatory and several elective modules. Within the UK, there are significantly less accredited human factors degrees than aeronautical or mechanical engineering, and you can see the numbers there. In the UK, there are 9 accredited human factors degrees, 83 aeronautical degrees, and over 1,000 mechanical engineering degrees. So the ratio is completely skewed wrong. We do see an increasing trend in universities blending specialisms into their curriculum, into those elective modules such as material science, reliability, risk analysis. The group found that it was notable that there's no significant effort yet to blend human factors or maintenance theory into aeronautical, in particular, bachelor's or master's programs. But looking at our future plans, the Society is engaging with the Institute of Apprenticeships in the UK to ensure that human factors content is embedded into the latest Trailblazer Aerospace Level 6 programme. We are also working closely with Cranfield University staff to encourage more students to do research into human-centred design for maintenance. But that said, more needs to be done to broaden university uptake of HF, and we would really like to see when universities are blending specialisms, into their degree programs, is to get HF and maintenance embedded more into their elective modules. So that's looked at the formal sort of grassroots training of engineers. But once engineers are in industry and have a job, there is a general lack of awareness of human factors amongst engineering professionals tasked with design or air systems. There's also no mandatory training for engineers working in 21J organisations, so that's design organisations, to receive human factors or maintenance training. Now, I'm going to compare that to the civil maintenance, the 145 organisations again. Maintenance organisations are required to provide that human factors training to staff, applicable to their work context as well, on a 2-yearly basis. Similarly, Defence Air Environment personnel, that's DAE personnel, are required to receive human factors and safety management systems training applicable to their work context on a 2-yearly basis as well. So really looking at the wider industry, it's only really the 21J organisations that don't have to embed this, this human factors training into their staff. Looking at civil organisations again, we found that embedded in their teams is a greater emphasis placed on fuel economy and lightweight structures when they're having their design reviews. Human factors doesn't come up as much as it should, and certainly design for maintenance doesn't come up as much as it should as well. When human factors is referred to in 21J organisations, it's typically used for flight deck ergonomics and crew resource management, which in part is driven by that new certification specification 251302. But that means that HF isn't really applied for other areas of the aircraft. Looking at future solutions, if we were to tell a civil organisation, a 21J organisation, that they have to train all their staff in a similar manner to 145 or military design organisations, there would be a significant cost implication. So maybe a more pragmatic approach may be designation of a human factors champion for aircraft programs, similar to how BEng is appointing their chief mechanic. That said, there are plenty of training courses available today in the UK accredited by institutes such as the CIEHF, the Chartered Institute for Ergonomics and Human Factors in the UK. And here, just to highlight some further reading for anyone else who is interested, I've put an excerpt there from the UK Military Aviation Authority, their regulatory article 1440, stating that all relevant defence air environment personnel should receive their foundation level HF and aero management training on a two-year continuation. And an interesting quote there from at the bottom. Now, this is an excerpt from the UK Civil Aviation Authority Human Factors Action Plan, which really is them admitting that training and tools at the moment remain as living resources, and they expect that there's going to be development of best practice and examples and guidance material to support further learning and developing a better understanding of what good looks like. So really what the CA have done there is acknowledge that there is an issue, and they've got an action plan to bolster that body of knowledge going forward, which is an interesting point, I think. Okay, so they're all the topics that the human-centered design for maintenance team looked into. We then came up with a set of summary and conclusions, which I'll flash up here. The main headlines really are: maintenance errors are still as prevalent today as they ever were, and there is a large hidden cost to industry. Human-centered design for maintenance could provide an additional layer of defense, taking the burden out of the hangar, out of the hands of the maintainers, and being shared across the design organization as well. We must give maintenance the same level of attention as it's given to the flight crew in 1302. There is a need to recognize and accept human adaptability, as a core asset. We can't just rely on the procedures being followed in the maintenance manuals each and every time correctly. We should accept that errors will occur, and that errors are a failure of the whole system of maintenance and not of individual maintenance engineers. In general, there's a failure to adopt processes which ensure consistency between that consistency of maintenance as done by the engineer, maintenance as prescribed, and maintenance as imagined by the designer. Now, there are some things we can do to address this, which brings me on to really almost my last slide. The recommendations we came up with over 40 recommendations, which if you want to see every single one, I'd encourage you to go and dig out the human-centered design for maintenance report. But what I've tried to do here is pull out 6 really salient points, which are, firstly, recommending that professional engineering bodies such as the Aeronautical Society, but also the IMechE, the IET in the UK, to accredit engineering degrees with human factors content. and they may do that. They may want to do that in partnership with institutions like the CIEHF in the UK or the IHFES, sorry, in Ireland. It's recommended that action be taken to develop apprenticeship programs with HF content embedded in them. It's recommended action be taken to introduce in 21J and other regulations initial and refresher human-centered or just in general human factors training. Regulators should develop further human-centered design guidance material in paragraph 2.5 of 21A3BB, because at the moment there is just one paragraph for human-centered design. There should be more. Penultimately, action taken to develop specific guidance, i.e. a human-centered design handbook for designers within design organizations. And lastly, action be taken to initiate rulemaking activity to develop requirements, that is certification specifications, and the AMC as well, and guidance material to put human-centered design at the heart of the design process. So last slide from me, I promise. The next step that the society has taken. So we're actively involved with, I mentioned before, that safety issue 9006 working group. We're encouraging human factors content into the latest level 6 aeronautical engineering apprenticeship standard, advocating study into human-centered design for maintenance in collaboration with Cranfield University. We're also trying to maintain a steady drumbeat of human-centered design for maintenance communications through the society, through conferences, magazine articles, etc. And I've just listed there below some other topics of interest that we're not actively involved with at the moment, but certainly remain that certainly remain on our radar. Sorry. Okay, so that is the formal presentation finished there. I certainly welcome any questions that anyone has. I haven't been keeping an eye on the chat, but hopefully someone has.
Great, Karl. Thank you so much. Can I just ask you to stop sharing, please, and then we'll be able to see people. So people are more than welcome to put on their cameras and to ask questions, to raise your hand if you want to ask a question. I see some coming in, Karl. So, but just to say, I found that really interesting. There's some of us on this who belong to a group in Trinity called the Aerospace Psychology Research Group. When it existed, it's changed its name now to the Center for Innovative Human Systems. But all of us worked in aircraft maintenance, so it's bringing back lots of really good memories. Also a bit disappointing to hear, because I remember we were involved in Airbus, and we wrote a guide for Airbus engineers at the time, you know, to take on human factor considerations into design. So it's a bit disappointing or I know you mentioned Airbus has been one of the leaders in the field, which is great, but yeah, I'm just a bit disappointed to hear that it hasn't been advanced as much as we would have hoped over the last 20 years, say. But you did mention Airbus leading the way.
Yeah, there's a lot of good practice. I guess the issue at the moment is trying to make that industry wide and really get it embedded into the mindset. Yeah.
Yeah. Okay, listen, we'll go to the questions in the chat, and then if anyone just wants to put up your hand, we'll come to you then. So from Kyriakos, I hope I pronounced that right now. I'm sorry, apologies if I didn't. Are there any plans from engineering accreditation bodies like the UK Engineering Council via the institutes to address human factors education gaps identified by your work for aero engineering degrees and more broadly in mechanical and other degrees?
I guess the simple answer is no, not at the moment. Usually within the UK, the accreditation for degrees comes from the society, such as the Aeronautical Society or the IMechE or the IET. So we're certainly trying to engage our society to start doing that. I think it would have to be in partnership with in the UK with the CIEHF. which is a really interesting proposition. I think there's a lot of mileage in that. Yeah, I think you're talking about the Engineering Council as well. So we approached the Engineering Council about the UK engineering spec. Now, the sort of barriers we came up against in terms of professional registration with the Engineering Council was that the Engineering Council is applied across the board, so all the way from software engineers to nuclear engineers, and a lot of those, there's not a lot of human factors involved with some of those, which is absolutely fine. So I think for professional registration, one of the interesting things is it would be down to the individual society or institute to apply those human factors contextually when engineers come to get their chartership. But it's a very interesting topic, that one, actually.
Can I add something here?
Yes.
Thanks for the answer, Karl. So in terms of the Royal Aeronautical Society, there are some standards which differentiate some aspects that, you know, aeronautical engineers should be capable of performing as part of their, you know, future career. So one of that is, for example, the requirement for programs to show that there is an element of flight testing. Are there any ideas to push similarly for, you know, aerospace, aeronautical engineering related requirements in the accreditation standards before, you know, the human factors education could be more broadly applied to various, you know, to a broad array of engineering degrees?
Yeah, I think that work is in its infancy at the moment, but it's one that we're investigating. I mean, our work with Cranfield, we're kind of going top down as opposed to bottom up. So our work with Cranfield that we're doing, we're encouraging more and more students to do their theses in human-centered design for maintenance. Your thesis is typically the last thing you do your thesis is typically the last thing you do as part of your degree. So really, we're going backwards with that as opposed to grassroots upwards. But it's a real interesting topic, and one that I think we should try and keep the conversation going with, to try and bring the human factors content right from the back end and bring it right to the front end if we can. Yeah.
Brilliant. Thank you, Karl. Paul, we'll come to you. So you have your hand up, and then I'll go back to the chat questions.
Yeah, so thanks, Karl. That was a really interesting presentation, and a step into my past as well, because I'm one of those researchers who worked in aviation maintenance. I did my PhD on human factors competence in aviation maintenance. I also studied in Cranfield, so this is my it used to be my bread and butter. It's not anymore. And like Marie, I'm disappointed to see that they haven't made as much progress as they might have, like as a discipline, let's say. But it's heartening that EASA is it's got it on its radar, human factors kind of in terms of design and everything. So my question is, did you find any evidence for maintenance engineers themselves trying to compensate for the lack of bad design, or not the lack of bad design, but the lack of integration of human factors into the maintenance, or poor design, whereby they were kind of coming up with smarter, more efficient, sometimes not approved ways of doing things? Or did you look at that at all?
We tried to. I mean, inevitably, that yes is the answer. That will be happening, because we were relying on the AAIB reports really to inform us of where things have gone wrong. I guess the way we did the research was looking at where things have gone wrong rather than where things have gone right. And part of that problem is that when things do go right, they don't get reported, right? We don't really celebrate it when engineers overcome difficulty. It's just part of their job, which is a real shame. And it's another one of the recommendations that I didn't flash up was actually to go out there, look at good practice in the hangar and really champion it, because with human variation, humans can humans can err, but also humans are innovative and they do overcome problems. Yeah, you're absolutely right. So it's a real interesting area of potential research.
Yeah, because we did some kind of ethnographic studies, and we found that the way the tasks were described to be performed, it was impossible. And so you had engineers who had workarounds, and they had unofficial pieces of tools and stuff that they would use. And when you might quiz them on what they've done to improve it, long term, rather than just getting the job done, they had no faith in the process with the manufacturer. So they were feeding back suggestions for improvement, but they just weren't being actioned. So they lost all faith in that kind of feedback process with the airline. I don't know if that has improved since. No.
The regulation certainly hasn't improved because the regulation very much puts the onus on the design organization or the OEM to essentially filter through all the reports they have coming in and decide which ones get priority and what action is taken. So the regulation certainly hasn't improved. When we were looking at the accident investigation reports, we found where the AIB made a recommendation, which is, it's going too far then really. If the accident investigator is making the suggestion, then it's too late really. But they were typically implemented in about 1 in 3 cases. And then in about 1 in 7 cases, design organizations went off and did some proactive work as well. Where they went and did something proactive, it was typically into the AMM. And I think that is because changing the AMM is a lot cheaper than changing the design or changing the tooling as well, which is sort of understandable. So I guess my answer to your question is not as much as they should. I think there's a real opportunity to do more, particularly with something lower cost like the maintenance manuals.
Yeah, and I think your suggestion about, sorry, and then I finished. Your suggestion about integrating human factors into education programs for engineers and stuff, I think that's definitely there's potential there, because what a lot of the maintenance technicians were telling me was, look at this manual. Sure, you can't do it that way. It's impossible. And the people who write this have never been on a shop floor or in a hangar working with these things. They're engineers. They're qualified. They're trained. They know how to write a manual, but they don't know the context in which it's going to be operating, the stress, the pressure, all the other kinds of things. So hopefully, integrating human factors principles for design into education will help kind of target the issue with maintenance there. So yeah, fingers crossed, because there's still progress to be made. And then I'll shut up.
I'm not rushing you, Paul. Okay, so we go back to the chat questions. Pratik, our DGCA approved CAR 147 aircraft maintenance engineers approved to work on EASA Part 145. If not, what's the procedure and eligibility criteria to get involved to get an EASA license?
So we didn't really look at the 145, 147 license. Are you able to just present that question? Sorry, it's quite long. I'd want to be able to answer it properly.
It's in the chat, Karl. Can you see the chat?
Yeah, just let me pull it up.
So, or Pratik, if you're still here, do you want to ask it in person? Are you still here? No, he can't talk at the moment. Yeah, okay. Can you see it, Karl? Maybe you could answer that one in the chat after, Karl.
Yeah, let me have a think about that. And
yeah.
Even if I have to email everyone, I'll make sure I get an answer to that.
Okay, and then Kieran, are there any plans to look at what is happening with EBT on the flying side to develop human factor competencies in both design and 145 at initial and ongoing training?
EVT, you mean eVTOLs, the sort of new air taxis?
Is Kieran still here?
Oh, EVT. Sorry, I can see the
EVT.
question.
Sorry, I think I might be on with you here.
Yes, Kieran, we can hear you.
Yeah, I can hear you. Yeah, EVT.
Yeah, Karl, I was just coming at this from evidence-based training. So I know you're after presenting a great presentation, and you're sort of far behind on a lot of the areas with basic HF training. But I was just wondering whether you ever touched on in your research the route that the flying side is going, which is evidence-based training, which is basically integrating HF and CRM competencies into the whole scheme of things, from starting with initial pilot training on things like situational awareness, decision making, communication, which is down the tracks a bit probably from your point of view, but just wondering whether you touched on that at all in terms of the potential for that being integrated down the road into engineering training and ongoing operations.
No, is the honest truth, but it's a really interesting, I know EVT now. It's a really interesting aspect, and I know a lot of maintenance organizations are bringing in competency matrices as well, and competency-based training. I think within a design organization, competency-based training or assessments certainly would work very well. And I know some companies have started to bring them in. It would be a really interesting topic of research, I think, EVT. And yeah, as I said before, with chartership, it's typically peer-to-peer assessment. And I think bringing in evidence-based may be a really good idea for that. Yeah, it's a really interesting point to raise, actually. Sorry, I don't have a better answer for you, but it would be a really interesting area of research.
Great. Thank you, Kieran. Thanks.
Thanks a lot.
Karl. Yeah, Anna, did you want to come in? You had your hand up there for a moment.
Yeah, just an observation now, because I have, hi Karl, talking to you online now again. So I really liked your presentation, and as myself, I speak from experience in maintenance research, aviation maintenance research, and healthcare background and research in healthcare. Human factors is a big element, big area of discussion within all complex systems such as aviation, healthcare. And I personally believe it's very fundamental for everyone to be trained, to have a basic training in human factors when they're looking to work in areas like that. And unfortunately, at the minute, all third level education that leads to qualification and registration in these areas, they do not have human factors training or education. And it's something up to the individuals into these institutions, like educators or admin, to bring these modules into the training. So there is no system, as we know very much. We have evidence that this training is essential, but we do not have this as mandatory training anywhere. So hopefully we'll try. We need to do something, I would say, about it. And I don't know, Marie, best there, how to put that into the mandatory training within these programs. That's something I think and your report is brilliant. I mean, it does, focus on that. And I think we need to work more, and our association is working towards that as well. It is one of the works that we do here, trying to gather all practitioners and all human factors experts together and try to get human factors into this training and education. So
yes, absolutely, Anna. Yeah, no, it is. I mean, you know, it's the same in healthcare where I work now. You know, there is no mandatory training at all in human factors. It's recommended for different things in different areas, but there isn't. So there's a lot of people undertaking postgrads, as Anna said, on their own, you know, off their own backs. But it's not integrated in undergrad training. Yeah, I just
and I would say, yeah, sorry, Marie, like it's a very important element for someone to have it within their undergraduate studies.
Yes.
In aerospace, aeronautics, or healthcare, I think it's something that you should start with, have it in your baggage, and then use it in your work, and definitely every 2 years a refresher. And definitely regulations should come through, the human factors perspective. Everything, human factors should be always present. Either we produce regulation, or we are just creating systems, or we're just, organizing our daily work. It's a very basic element. It should be present. So, yeah.
Yes, absolutely, Anna. Yeah. Kevin Hayes has answered one of the questions. Kieran, your question: ICAO have issued evidence-based training guidelines for maintenance training, and it's been rolled out in some Part 147 organizations. And then Hannah is just commenting that she lectures a human factors module on the aviation technology degree with the sustainable transport degree with TU Dublin. But she also sees the gaps from design side, human-centered design, into Part 21 organization and training. Yeah, so it's great there is some undergrad training happening. So any last burning questions, or we might just wrap up by telling you just about 2 upcoming events, if that's okay. You think about any last burning questions while I share my screen again. So yeah, so just any last questions for Karl? People okay, great. So just wanted to let you know about 2 upcoming events. So one is a group of us in the Chartered Institute of Ergonomics and Human Factors in the UK have been working on a guide for clinicians and for healthcare staff for human-centered AI. So there's a webinar on Tuesday. So the guide is called Integrating Human-Centered AI in Clinical Practice, a guide for health and social care professionals. And there's a webinar Tuesday at 4 p.m. if anybody wants to come along. If you just look on the Chartered Institute website, the details are there and you can register there. And then we're delighted to say that our next webinar is not a webinar, it's in person. So we're having our next gathering on Thursday, the 12th of December at 4 p.m. Our next talk, and that is the insights of human factor ergonomics practitioners in high stakes environments. And it's with Colleen Butler from the Health and Safety Authority, the HSA, Nora Balt from Irish Rail, and Diego, who's with us today, from the UK Atomic Energy Association. So that's in person in TU Dublin on the 4th of December, and we're having a reception to follow afterwards. So everybody's more than welcome to come along to that if you are based in Ireland. So any other advertisements, or anybody want to share any other events before we finish up? Great. Okay, well, just to say, as Anna said, the certificates of attendance, if anybody wants to email us. And just last thanks to Karl. Karl, thank you so much. We really appreciate your time. As we said, we're a volunteer society, so we're all volunteers here, including you today. So thank you so much for sharing.
No, thanks for having me. And yeah, if anyone wants to has any follow-on questions, just find me on LinkedIn and message me any questions you'll have as well.
Brilliant, brilliant. Okay, thank you so much. Thanks, everybody. Thanks for attending, and hopefully see you next Tuesday or on the 12th. Yeah.
All right.
Thanks a lot. Bye, everybody.
Bye-bye. Thank you, Karl. Thanks. Bye.